Today we will multiply polynomials and use binomial expansion to expand binomials that are raised to positive integer powers. When multiplying polynomials, you're just going to use the distributive factor. In this example, we're going to distribute the xy times each separate term in the polynomial that we're multiplying it by. So x squared, so we're doing xy times x squared plus xy minus xy times 2x squared y squared plus xy times xy squared. So we have 1x here, 2x's here, that's 3x's, 1y. We have a constant of 3, 1x, 2x, that's 3x's, 1y, 1y, that's 2y's, minus we have a 2, 1x, 2x's, that's 3x's, y, and y, 1y and 2y is 3y's, x, that's x squared, y cubed. All right, now we're going to see if we have any like terms. So we have to have the same exponents for x's and y's. And the only terms that we have that in common with are these two. So we're going to bring this x cubed y down, and a positive 3 minus 2 is just a positive 1. Oh, never mind, they're not even the same. Because this is y squared and this is y cubed, so they are not the same. So this is our final answer here. All right, we have x plus 2 times x squared minus 2x plus 1. Again, we're going to use a distributive property. We're going to distribute the x first. So we're going to distribute our first term. So x times x squared is x cubed. X times negative 2x is negative 2x squared. X times 1 is x. Now we're going to distribute our positive 2. 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. 2 times 1 is 2. Now I'm going to combine my like terms. I'm going to start with my highest power first. So that's x cubed. There's only one x cubed, so I'm done. Now I cross them out when I'm done with them so that I don't need to look at them anymore. That way I can just look at what I haven't used. So I have a negative 2x and a positive 2x. Those are just going to cancel each other out. So there's no x squareds in here. X minus 4x is negative 3x, and then plus 2. So this is our final answer. All right, and let's look at one more example of multiplying. What if we had x squared minus 2x plus 1, x squared plus x minus 2. Again, we're distributing. So x squared, that's x to the 4th. X squared times x to the 3rd. X squared times negative 2 is negative 2x squared. Now we need to distribute the 2 to all three, the negative 2x. So negative 2x times x squared is negative 2x cubed. Negative 2x times x is negative 2x squared. Negative 2x times negative 2 is a positive 4x. And then we distribute the 1, which is just going to be this polynomial because 1 times anything is itself. So now we have plus x squared plus x minus 2. So now we need to simplify this by adding like terms. X to the 4th, there's only 1. X cubed, I have an x cubed here and x cubed here. So 1 minus 2 is negative 1. So now I use those. Then I have negative 2x squared, negative 2x squared, positive x squared, negative 2, that's negative 4, plus 1 is a negative 3. So we use that, we use that, and we use that. We have 4x and x, so 4 plus 1 is 5, and then a minus 2. So x to the fourth minus x cubed minus 3x squared plus 5x minus 2. Now I want us to look at Pascal's triangle. And this is just more for notes. I'm going to show you how to make Pascal's triangle and how to use Pascal's triangle here in a minute. But this is what Pascal's triangle looks like. It's helping you figure out the coefficients of a binomial expansion. And we'll look at this more in the next example. Okay, so let's look at how to build Pascal's triangle, and then we will look at how to use Pascal's triangle. So to build Pascal's triangle, you just start with 1. And then you're always going to start and end with 1, adding one more term each time. So 1 and 1. But we need something here in the middle. So all we need to do is add the 2 terms on top to get this term right here. So 1 plus 1 is 2. So now I have 1. 1 plus 2 is 3. 2 plus 1 is 3. And then remember, I start and end with 1. 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1. 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And I'm going to end with a 1. I'll do one more. 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And 1. All right, so we're going to use this when we're talking about having a binomial and raising it to a positive integer power. So like 2x minus 3 to the fourth. So how do we use this and Pascal's triangle together? Well, with Pascal's triangle, what you're doing is you're thinking about the degree you're raising it to. So 0 is going to be your top, and then you go down 1, 2, 3, 4, 5, 0, 1, 2. This doesn't line up really good. Let's try a different way. 1, 2, 3, 4, 5, and 6. So these are the degrees here. So the first thing you need to do is look at your binomial, what power you're raising it to, and then we're going to look at, let's do a different color, which row that lines up with. Now I'm just going to write out these numbers with spaces. So I have 1 plus 4 plus 6 plus 4 plus 1. The next step I'm going to use, I'm going to look at this term here, and I'm going to start from the left, and I'm going to put it in, and I'm going to raise it to whatever power it's being raised, the binomial is being raised to. And then I'm going to take away 1 each time. So I take my first term, I raise it to the power that the binomial is being raised to, and then I start there. So 2 to the fourth power, and then I take away a power each time. 2 to the third, 2x to the second, 2x1, and then 0. Next, I'm going to take my second term, and that's going to be raised to the 0 power, then the first power, second, third, and fourth. And if you look at all these powers, you should be able to add the exponents together to get the power that we started with. 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and 0 plus 4 is 4. Now I need to simplify this. 1 is just 1. We don't really need to add it in there. Negative 3 to the 0 power, anything raised to the 0 power is 1. So I have 2x to the 4th. So I need to raise 2 to the 4th power and x to the 4th power. All right, so negative 3 times 4 is negative 12. And then we're multiplying it by 2 to the 3rd power, x to the 3rd power. Negative 3 squared, that's 9. 9 times 6 is 54. And then 4x squared. Negative 3 times 3, that's negative 27. Negative 27 times 4 is negative 108. Times 2 is negative 216. 1 is just 1. Anything raised to the 0 power is 1. So 3 raised to the 4th power is 81. All right. All right, now we can simplify this a little bit more. So 2 to the 4th power is 16. So 2 to the 3rd power is 8. 8 times 12 is 96. And then 54 times 4 is 216. And that is your answer. And that is how you make and use Pascal's triangle. If you'd like more practice on this, you can go to IXL, Algebra 2, Section L, and then 3 is multiplying polynomials together. And 17 through 20 is all about using Pascal's triangle and binomial expansion. See you in Zoom.